Hi friends, my name is Bhavya Mangla and today I have come with another interesting topic that is related to process design. It's a series which is going of 8 episodes. The first one was with respect to the overall product and process design process. The second one was with respect to the planning phase. The third one with respect to the product design phase. The fourth one, this one is with respect to the process design phase. The fifth one will be with respect to the process and product validation. The sixth one will be with respect to the corrective action, feedback, and what actions that we take with respect to the new product development process. The seventh one will be with respect to the design changes, the ECN that happens, and how to deal with that. The last and the eighth episode will be with respect to what are the challenges that an organization faces with respect to design and development process and what can be done with respect to that. So now in this episode, I'll be talking specifically with respect to process design phase. Somebody has very rightly said that designing is just like a refrigerator. As long as it works good, no one notices. But when it does not, it stinks. Something similar happens in the process design phase. Because this is a phase where we actually can see a tangible product in our hand. And if it does not meet the input requirement which is coming from the customer as well as from the previous phases, it will not meet the customer requirement and it will lead to customer dissatisfaction. So it's very important that whatever inputs that an organization or that process owners they are receiving from the previous phase, they must incorporate them effectively so that this phase, whatever output is coming, that fulfills the customer requirement. If I talk about some of the key inputs which are coming from the product design phase, that includes engineering drawing, engineering specification, material specification, then control plans which may be related to prototype control plan, DFMEA, identification of special characteristics, reliability studies, identification of design for manufacturability and assembly, and many other things. All these things become key input for the product design, process design phase. So what can be the possible outputs with respect to the process design phase? So I bifurcated them into two parts. One is in the form of documentation, which is a preparation part, and secondly, based on that documentation, what are the outputs in terms of some other things that comes out of that. So some of the key documentation that are being prepared at this stage is preparation of specification and sub-assembly drawing. Say for example, in a press shop process, there may be many sub-processes, blanking, drawing, trimming, and maybe other processes. Now we may be having one complete assembly drawing. So what about these processes? So there can be some specific drawings, sub-assembly drawing for this, and there can be specific specifications for each stage, that what will be the dimension for each stage. So that is one of the key output of this stage. Then process flow chart is another key output of this stage. Process flow chart talks about sort of a complete thing in that entire process, that from incoming inspection to the dispatch, how the process flow will move, and that also helps in the PFMA stage also to identify what can be the possible variation in the 4M, man, machine, material method also. Once the process flow chart is prepared, it's very easy to identify and prepare another document, that is floor plan layout. Now the floor plan layout is basically that in the entire workshop or in the factory, how we are going to place the different things. Say for example, where the press shop will be there, and then from press shop when the material is going to come out, if it is going to the painting shop, what will be the flow, where intermittently material will be kept in different stages, where we are going to do the reworking, say repairing, where we are going to do the packaging. So all those things are being clearly defined in the floor plan layout. One very key important thing in floor plan layout is to ensure that there is a synchronous flow, the movement of operator is very less, and how to utilize the floor space as effectively as possible. Once the floor plan layout is ready, it's very easy to go to the next step, that is with respect to characteristic matrix. When we say characteristic matrix, it is a relationship between different processes, say for example molding process, heat treatment process, and what are the key parameters which are working there. For example, in molding process, maybe the key indicator is with respect to the temperature which is there in the injection. Then in the heat treatment process, it can be the time and temperature. So what is the relation between that particular process and with respect to that parameter? In case there is a variation, what can happen with respect to that? So once we make a characteristic matrix effectively, it becomes a very good input for the next stage, that is related to process FMEA. So the process FMEA talks about what can be the possible failures that can happen in the process, what can be the failure modes, what actions can be taken, maybe with respect to detection and prevention with respect to that. At the moment, AIG VDF first edition is quite popular among people, but in case there is a customer requirement, organization can use that also. Generally, FMEA is considered to be a live document which should keep on change from time to time, and there can be different reasons for that. Maybe at a certain periodicity, organization can review PFMEA. Maybe in case there is a customer complaint, or in case the rejection is coming, or there is some improvement that is happening in the process, or there is any forum change. So all those things can result in change in FMEA. Once FMEA is ready, it becomes a very good input for making pre-launch control plan. Now, pre-launch control plan is nothing but a control plan which is being made just before the mass production, just to see that whether all our processes are ready to make a good quantity of product. Like in PPAP stage, generally it is said that we need to make around 300 pieces, or maybe as per the customer requirement, it can be less or more. So in control plan, generally we define the characteristic with respect to process and product. We also define the controls, the inspection criteria, foolproofing, and many other things. One key difference between pre-launch control plan and the mass production is that here the inspection frequency is little bit more, the sample size is more, there are more focus on the error proofing, and there is a very detailed focus with respect to the process capability study to verify that whether process is capable or not. One very important output at this particular stage is also the error proofing methods, or the stages where we need to provide the error proofing. The objective of error proofing is to ensure that either we can avoid any defect to produce, or in case it is being produced, it can be detected immediately so that actions can be taken. And that becomes very key input with respect to the control plan process. Once these documents are ready, it's very easy to make the next document, that is a work instruction. Now, work instruction is a document which is to help the operator and the supervisor to do their work at their place. And what are the inputs which makes the work instructions? It can be control plan, PFMEA, customer requirements, specifications, drawings. All these things becomes good inputs for the work instructions. It's very important to ensure that work instructions should be in a language in which the operator can read, and it should be easily accessible to the person so that they can refer to it as and when they want. Once the work instruction is ready, the next important thing that is there is with respect to the acceptance criteria. Based on control plan, now how to actually make the product based on certain parameters, certain guidelines. So that is a job that is being done by the acceptance criteria. So in acceptance criteria, the intent is that for different process parameters, which can be attribute or variable, there are some tolerances which have been specified. There are certain do's and don'ts, some master samples, so all those references comes in the acceptance criteria so that it becomes easy to make the final product. Then at this stage, it's very important to identify the maintenance plan also. The objective of maintenance plan is to ensure that the machine work as per the plan and they should not be under breakdown from time to time. So based on the machine manuals, based on the previous experiences, organization decide the plan for predictive maintenance and the preventive maintenance. At this stage, it is also important to identify the critical spare parts which are needed, that in case a machine goes under breakdown, what needs to be done to ensure that machine can be repaired immediately. Once all these documents are ready, then some tangible outputs that come. One is in the form of MSS study, Measurement System Analysis, which is a 4th edition as per AIG manual, or it can be another manual which the customer may prescribe. The objective of MSS study is to see the possible error that can come from the measurement system. So as per IATA 16949, there is a requirement that all kind of measuring instruments which are specified in the control plan, they should be a part of MSS study. Once this study is being conducted, the next logical output is the process capability study. So in process capability study, whichever instruments which are approved or which are within some guidelines of MSS study, they are being used. And this capability study is being done for all the special characteristics which have been identified from DFMEA, PFMEA, and which are specified in the control plan. So for all those things, SPC study is being conducted just to see that how much stable is our process, how the process is moving from time to time, and what needs to be done as an action to make sure that the process remains stable and within the specification or the capability which is it is intended for. Then the next tangible output with respect to this stage is the reliability, quality, and maintainability study. So there are certain targets which are initially given by the customer with respect to the quality, reliability, and maintainability, and many other factors. So at this stage, based on the production lot that is being prepared, it can be seen that whether organization is meeting those targets or not, or in case there is any gap, what needs to be done with respect to that. Then the next output is capacity analysis. Now, in journal, initially there are certain targets that are being set, that what will be the production volume every day, every week, and every month. So based on this production trial lot, it gives an idea based on the run rate study that whether we will be able to meet the customer requirement in long term or not. And if not, what needs to be done with respect to that. Another output at this stage is with respect to the rapid detection mechanism with respect to breakdown and other things. It's also very important to see that in case any breakdown is happening, in case there is any variation in the process or the product, how quickly our process can detect that gap and what action can be taken at this particular stage so that the process runs smoothly and whatever productivity targets are there, they can be met effectively. Then the next stage is with respect to the review at this particular stage. That in different stages of process design, the cross-functional team needs to review its performance, that whether we are meeting the timeline, whether we are meeting the customer expectation, and in case the cross-functional team is not able to meet the timeline or whatever target that are being set, then it can be escalated to the top management. So the top management can help and they can give more resources, they can give their own inputs, or they can offer some alternate solution what needs to be done so that whatever agreement organization has done to the customer, that can be taken care with respect to that. So if you see broadly, I talked about the key outputs which were related to preparation of subassembly drawings and specifications, process flow chart, characteristic metrics, floor plan layout, identification of error proofing, preparation of maintenance plan, and then based on that, preparation of Fmea, preparation of pre-launch control plan, work instructions, acceptance criteria, MSA study, SPC study, reliability studies, the study of capacity analysis, and the CFT review with respect to the entire process design process. And in case all these things are being done effectively, what can be the possible benefits? Certainly, it will result in ensuring that whatever quality and the productivity targets that we have set with the customer, will be able to meet that and customer will be satisfied. It will also ensure a good relationship with the customer. It will also help to increase the morale of the people who are working in this particular team. But what can be the possible challenges the industry may be facing at the moment with respect to the process design phase? The first one and the most important is that how effectively cross-functional team is actually working with respect to the process design phase. Secondly, in case of any issue and challenge, how often it is being escalated to the top management. Thirdly, how often a structured review is being done with respect to the process design phase to see that whether things are going right or not, and if not, what needs to be done. And lastly, do we identify what is the competency requirement for this particular development phase? And in case there is a gap, are we bridging that gap to ensure that the capability can be improved so that the development process can be done in the way in which it is expected? Well, so this is the fourth episode of this entire series. The next part will be with respect to process and product validation. In case you want to understand a little bit more about this video, you can click the below link. You'll find a blog there, and there you'll find more detailed information there. And if you're liking this video and if you want that these kind of videos should regularly come to you, so you can subscribe to my YouTube channel. Thank you.